Okay, so hello everyone. A very good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 6B. My name is Anisha Mishra, and I am the moderator of today's session. So on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress on Information and Communication Technology, ICICT 2023. The 8th edition of the conference is being organized in a hybrid mode, and the physical event was held in London, UK on 20th and 21st February 2023. And the virtual event is being held through Zoom yesterday and today, that is 22nd and 23rd February 2023. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chairs of the session. Our first session chair is Dr. Shyam Akashe, but he has not joined the session yet, so we are waiting for him. And our second session chair is Anna Topol. So Anna Topol is the Chief Technology Officer at Global Think Labs, IBM, United States. She has 100+ publications, 3 book chapters, and 90 patents. She has 20+ years of experience in both technical and business development positions, lead roles in strategic R&D outlooks, intellectual property management, joint research activities, and fundamental technology development. Her special interests are research development, problem solving, public speaking, business development, innovation, industry solutions, R&D, analytics, big data, social media, technical strategy, marketing, and strategic partnership. So I welcome you to the session, ma'am.
Thank you. And thank you, Manisha, for your kind introductions. And most importantly, thank you to all the speakers who are participating with us today. And a reminder to everybody, please engage in a chat so that we can really benefit from each other's knowledge. Thank you.
So yeah, so for now, we are moving forward to our to the presentations. And I would like to invite our first presenter, Miguel Angel Samaniego, to present his paper on the title, A New Method and Case Study for Predicting Tutoring Performance in Students at the Universidad Politécnica Salesiana using data science and support vector machines. So dear presenter, you may please present your paper now.
Hey, good morning, everyone. I apologize for my camera. I have a little problem. Okay.
We can see your slide. Thank you.
Okay, thank you. My name is Miguel Samaniego, and I'm going to explain the following topic: a new method of case study for predicting tutorial performance in the student in the Universidad Politécnica Salesiana using data science and support vector machines by Remigio Hurtado, Luis Adrián Cabrera, and myself, Miguel Samaniego. First, I want to give an introduction. In recent times, it has become evident that higher education is of utmost importance, and that student performance is the case to a better future. That's why the group JETAES and as ayudantías estudiantiles within the Universidad Politécnica Salesiana offer pair tutorials. These are from students to students, as we want to more fraternal and easier relationship. One of the advantages of the pair tutorial is that the students are free to ask a relevant question. At the Universidad Politécnica Salesiana, pair tutorial are offered during the academic cycles. There are students of the higher level who studied with outstanding average. They help students who study subjects with high reputation rates. Their tutorials can be of consultation type, where the student receives a quick tutorial or process tutorial, then later require several sessions over a period of time. There are also summer tutorial and intensive tutorial. The summer tutorial and the intensive tutorial is during 2 weeks, more or less. Okay, proposed methods. First of all, we analyze the data. In this case, the data was provided by the JETAES group. We normalize and transform the data, and then we do an exploration analysis. Then we use the prediction methods like KNN, random forest, and support vector machine. And finally, we make an evaluation and interpretation of the results. The data we have taken from each student is the follows. First, the grupo is the group to which the student belongs. Carrera is the student career. Materia is the studying subject. Nivel is the student's grade level. Edad is the student age. Colegio en el que se graduó is a college where the student graduated. Promedio de graduación is the student graduation average. Ciudad de origen is a city of the origin of the teacher. Quintil is the student quintil. This is about the economic of the students. Número de tutorías is the number of tutorial of the students. Número de horas is number of the hours of the tutorial of the students. Número de tutores is the number of tutors of the student has had. This is because the student needs 2 or more subjects, or they doesn't understand the first tutor. And the qualification is the final student classification is or out. Now, we have some parameters for the 3 methods. For superior vector machines, we tried with gamma 0.1, 0.5, 1, and y.5. The kernel is polling, linear, RBF, and sigmoid. And the C is 0.001, 1, 20, 15, and 70. For the KN, we have the neighbors 2, with 5, 20, 50, 80, 87, and 300. And the weights are uniform and distance. For the random forest, we have the N estimator. We use 20, 40, 60, 100, 150, and 200. And for the max depth, we use none, 5, 15, 30, 35, and 40. And the random state like is 0. We use some quality measure like the precisions, recall, F1 score, and the accuracy. We are looking at the accuracy especially. And we have the variable correlation matrix, and we can look the parameters we have many of variables are positive correlation with the final grade. We have the final grade in this, and we have correlation positives with edad, promedio de graduación, número de tutorías, número de horas, and número de tutores. Now, we have the final values of each method. This is the base for each method. For the superior vector machine, we have the gamma, we use 1, the kernel, RBF, and C with 70. For KN, the neighbors, the base with was 2, and the weights with the distance. For the random forest, we have the N estimator with 200, max depth with none, and random state with 0. Now we have the comparison of the methods. We have 3 methods, like KN, SVM, and random forest, and we have the comparison with precision, recall, F1 score, and the accuracy. With KN, the precision is 0.96, the SVM is 0.94, and the random forest is 0.95. With the recall, with KN, we have 0.78. With SVM, we have 0.85, and with random forest, we have 0.82. With the F1 score, with KN, we have 0.86. With SVM, we have 0.89, and the random forest, we have 0.88. For the accuracy, we have with KN 0.87, with SVN 0.19, and with random forest 0.89. And we can see the best is the superior vector machine for the prediction of the students. Now we have the conclusion, and we can say in the research and in domain analysis methods was provided that includes a machine learning. Following in the object, we predict whether or not a student will fail the subject. In the phase 1, it was obtaining as observation that the most relevant variables as the average graduation rate and the age in relationship with the exit variable. In the phase 2, we predict the methods to the best technique was a superior vector machine because it have the best accuracy of the 19%. The proposed method will improve the performance of the student in an education institution that has a tutorial. In the future, I think we need so many data because we have the data for 2 or 3 academic cycles, but if we have for 10 years, I think is very important to have a very big data to help us to help the students in the first levels, in the middle level, and the final levels, because in the final level, they can help the another students. Okay, this is my presentation. I don't know, we have so many questions, maybe not.
So again, for everybody, please kindly type your questions for the speakers in our chat. And I'll start with my question. If you look retrospectively of what you've accomplished so far, and you said you will continue, right? And so I'm sure you're looking at what else could be added and changed. What is the one thing you would want to change? Would you want to add more data, a different type of data? Would you want to try a different machine learning methods, or add more parameters? What do you think will enhance your method?
Okay, I think the most important is the data. We need more data for 10 years, 20 years. I don't know if we want more. Well, the university have 25 years. So if we can use the data, we can use a better prediction for what we're using a super vector machines or another method.
Thank you, I appreciate it. Any other questions?
Yes. Yeah, Good evening, good afternoon to everyone. My question to the presenter is that, as is mentioned from here, the 3 methods are like SVM and KN and another method. What is the best method for analyzing such important topics? I hope you
Uh,
understand. Yeah.
I'm sorry, I didn't listen you. I don't know if
Yeah, we
this
had hard time hearing you. Could you kindly repeat, please?
Yeah, please. I'm repeating the question. Which method is best for analyzing your particular works? I think, ma'am,
Ma'am, you're on mute.
you are muted.
Professor Sham, we really cannot hear. Your sound is breaking. Any chance you could kindly write your question so the author can respond? And Anisha, we can move to the next speaker
Yeah,
and kind request for the
Yes,
for
sure.
the speaker to reply in the chat. Really
yeah,
appreciate it.
please.
Thank you.
Please, Anisha, please move ahead from the another presenters. Please.
Yes, sir. But for before that, I would just like to introduce you all to another session chair for the session.
Yeah.
And Dr. Shyam Akashe. So Dr. Akashe worked as assistant professor at Institute of Technology and Management ITM Gwalior. Currently, he is working as professor and post-graduation coordinator, Electronics and Communication Engineering Department at ITM University, Gwalior. Dr. Akashe has authored and co-authored more than 200 research papers in peer-reviewed international and national journals and conferences. His areas of interest in research are low-power VLSI design, modeling, FinFET-based memory design, circuits for future VLSI technology, digital design, and FPGA implementation. So, Dr. Akashe, I welcome you to the session, sir.
Thank you very much. Thank you.
And
Now you please move ahead for another presenter.
Sir, your voice is not clear and we are not able to hear you clearly.
Okay, I will try my best. Yeah, please.
Okay. Yes. So now we'll move forward to our next presenter. And I would like to invite Deepa Kumari to present her paper on the title, An Experimental Analysis of Benchmarking Tools for Smart Contract-Based Blockchain Application. So dear presenter, you can please present your paper now.
Ma'am, it is not allowing.
Yeah, you can share it now.
Yeah. Okay. So, hello all. This is Deepa Kumari from BITS Pilani Hyderabad campus. My paper topic is an experimental analysis of benchmarking tools for smart contract-based blockchain application. These are the outlines here I'm going to cover, like problem statement, objectives, workflow, experimental results, conclusion, and future work, along with the references. So here I'm going to.
Dear Kumar, your presentation is not moving forward. We only see your title slide.
And now it is visible, like moving the slide.
Yes, now we're on your next slide. Could you kindly put it in the presentation mode?
Yeah, I'm keeping it in the presentation mode, but it's not visible at your end.
Okay, if you move it page by page.
Yeah, that's what. Yeah. So in the problem statement, actually, the blockchain is gaining more attention day by day, but there is no such standards to test the performance of various blockchain platforms before creating the solution of any business problem. To keep this issue in mind, blockchain benchmarking came into use, and benchmarking is the process of making standard measurements to compare one system to another or to previous measurement of the same system. So like there are some unavailability of the source code for the validating the blockchain performance evaluation, due to which it is challenging to perform the same assessment on the different blockchain platforms. And also there is the lack of the standard description of performance indicators and makes it difficult to identify the performance bottleneck. And there is also the lack of the typical standard benchmark use cases that make it difficult to understand the blockchain itself. So it is a requirement to explore the evaluation method and the benchmarking suite along with the strength, weakness, and appropriateness of usage. So, there is some also the concept behind the blockchain benchmarking works. Firstly, it loads the blockchain application and initiates the resource monitor. Then it calls a benchmark and blockchain configuration file for running that file test case B. And this test varies in block length and user counts. So it performs all rounds of R for different transaction rates, and later it generates a benchmark report after executing all the test cases. So what are the objectives of this research work? So we actually we have proposed manual benchmarking that reduce the cost of development compared to the existing tools by providing comprehensive, definitive, and unbiased results. It also satisfies the end user's requisites to accomplish long-term objectives. The research work also considers the essential metrics such as read latency, read throughput, transaction latency, and transaction throughput for the system's performance evaluation. And also to explain the steps for installation and configuration for suppose for the different types of the benchmarking applications in a more friendlier way, and also to present the impact of varying transaction numbers, transaction rates, and the transaction types on the blockchain performance have been discussed. So what are the benchmarking parameters? Those are the parameters that are going to evaluate the blockchain performance. And we in this paper, we have taken 4 metrics: read latency, read throughput, transaction latency, and the transaction throughput. Read latency measures the time between when the read request is submitted and when the reply is received. Read throughput measures of how many read operations are completed in a defined time period, and it is expressed as read per second. Transaction latency measures the network-wide view of the amount of time taken for the transaction effect to be usable across the network. And the transaction throughput measures the rate at which valid transactions are committed by the blockchain system under the test in a defined time period. So here so we have taken the record keeper smart contract. This table depicts the workload files for this record keeper smart contract, which is electronic health record keeper, and its descriptions. So here, actually, this smart contract automates the execution of an agreement on the set of predefined use cases. So it works on the script that is executed in the Ethereum virtual machine. This work uses Python interface to interact with the local node by Web3 Python and Brownie framework for the script. And these are the smart contract, like basic, like for the get name, get age, get doctor list, get image of ultrasound image or any type of the image. And we have also provided this functionality set name and set age, and also the any updation in the treatment details. So we have the installation steps in the Hyperledger Caliper. We have explained in a very user-friendly manner. First of all, Hyperledger Caliper is one of the benchmarking tools for the blockchain platform that generates a report for a blockchain with predefined use cases. There are also other existing tools such as Mixbyte Tanks, Byte Block Genesis, Bishol, but these platforms for this Ethereum blockchain, but they resemble Caliper in terms of the functionality. So this paper is chosen due to its wide acceptance and similar functionality. And there are several steps to perform Hyperledger Caliper to functionalities. Those are setting numerous nodes, conducting initial configuration process, executing the critical metrics, and choosing the test network. There are certain installation steps in the manual benchmarking also. So this one is the proposed one where this manual benchmarking provides with the customized parameter and implementation steps. Since Hyperledger Caliper is little challenging to install due to its software compatibility issues and also with the different Ethereum version. Since also the blockchain works with its initial scripts for making node accounts and prerequisites for the test. So these modifications are served differently in the different blockchain. So manual benchmarking makes it easier for users to slowly adapt testing and benchmarking for their products to improve testing procedures. Here we have taken certain steps like customized steps for evaluating the parameter. So we have taken the set of n signed transactions, and then the user node sends the created transactions to an Ethereum based Ganache blockchain and captures the current time point. Since the blockchain's peer-to-peer network distributes the transaction to miners, so the mining process will confirm the valid transactions and broadcast them to all the nodes in the Ethereum. Then the user node will continuously query the confirmation of each transaction through the Web3 module. When all the transactions are confirmed, the user node captures time and then calculates and records the transaction time. Here we have plotted the graph for the benchmarking with the Hyperledger Caliper. We have taken certain same like 4 parameters: transaction send rate, latency, transaction throughput, and the transaction number of the transactions. In the figure 4a, we have like reflects that mean, max, and average latency are at 0 till the transaction rate is 20 TPS. There is no delay for 20 transactions, but there is an uneven growth in latency after the transaction rate exceeds 20. Figure 4b depicts continuous growth in the average latency as number of transactions increases. So there will be the growth in delay with the number of transactions. In the case of this figure 4c, it depicts the transaction throughput increases on 10 to 20 and also further to 30. But after exceeding 30, throughput decreases due to the delay in the transaction. In the case of the figure 4D, it represents that as the number of transactions increases to 200, there is a small growth in the throughput, but throughput decreases after a continuous increment in the number of transactions. So in the case of the manual benchmarking, we have the figure, suppose in the figure 5A, we have this, sorry. Yeah, so in the case of the figure 5A, it depicts that there is a continuous growth in both read and the latency as the number of transaction increases. Similarly, in the figure 5C and 5D, depict the transaction throughput on 0 to 800 simultaneous transaction. They show that as the number of transaction increases to 150 to 200, there is a big growth in the throughput for both read and write operations. So in the case of the Hyperledger Caliper and manual benchmarking, we can analyze that that manual benchmarking customizes the performance indicators such as read or write latency and throughput, unlike Hyperledger Caliper. So Hyperledger Caliper is a predefined tool and new desired parameters can't be added. Moreover, Caliper uses Docker Swarm to unite virtual machines into a cluster. So one has to be proficient in Docker to be able to use the tool. So manual benchmarking is simple test configuration and also easy to use benchmarking. It also, we have made a comparison on the different scenarios for this. Suppose in the case of the platform, the Hyperledger Caliper is the modular blockchain platform, and manual benchmarking can be considered as a generic blockchain platform. And it is very difficult to install because of the software compatibility issues and also very less user interface. But in the case of the manual benchmarking, it is little easier, and also it depends on this Golang and Java on Linux Foundation smart contract code. And in the case of the manual benchmarkings, we can write the Solidity code on the Ethereum virtual machine. And there are the pros and the cons for the Hyperledger Caliper is like Hyperledger Caliper is the adapter-based framework, and also it provides the scalability, and there are the predefined workload. There is no predefined workload designs, but it supports more workloads. And in the case of the manual benchmarking, it uses the driver function to compile those code, and it is also scalable, but we have to carefully design the workloads because those are the constant. So there are some threats to validity work. This research work experimented with 2 benchmarking tools on the given smart contract. There are other benchmarking tools such as Blockbench and Bsolve. But due to the lack of proper documentation and poor user interface issues, Hyperledger Caliper is chosen over them. And the result analysis is carried out on the given smart contract, which can be difficult from other environmental setups. Still, this research work illustrates the performance in a user-friendly way. And most of the time, researchers find it difficult to set up a benchmark framework and deploy the application. So additionally, due to the dynamic nature of most public blockchain, the research faces difficulty in evaluating distributed ledger technologies. So the conclusion of the research work is like it performs the performance evaluation on both Hyperledger Caliper and manual benchmarking, and also on the, like, we have observed different behaviors of benchmarking patterns. Those are latency, throughput, and transaction send rate. And the benchmarking results conclude the performance assessment like heat rate, success rate, availability, consistency, and scalability. We are further moving to work on the other different types of the blockchain platforms with different number of transaction nodes to observe the influence of varying concession algorithms on variable workloads. And these are the references. Thank you.
I hope I'm audible to everyone.
Yes, sir.
Yes, thank you very much. Yes, this is a nice presentation, but my question to author is that, are you allowed scalability?
Scalability. Yes, sir. Sir, yes, sir. So there I can show the graph again, sir. So in the case of the benchmarking, we have taken like combinedly for the four, like this figure, we have analyzed on the transaction send rate concerning the throughput and latency. So it depicts the transfer of sending data in the specified amount of time to check the delivered throughput.
Okay, thank you. Yes.
I have a question for you also. Right now, again, this is more of, I really understand that's a semi-future of what else you can do, but I have a question for you. Right now, you're looking at the smart-based benchmarks, almost like for individual workloads for individual benchmarks. But as you commented in your abstract, in the future, we'll be going to multi-blockchain ecosystems.
Yes.
What do you think? How would your benchmark have to change to really look at the multi-blockchain ecosystems?
So, ma'am, actually, this is the manual benchmarking. So it totally depends on our choice that which like parameters we are going to choose for evaluating that blockchain. So it is all customized. So it's not to say that whatever I have implemented for the manual benchmarking is going to work for the same in the case of the multi-blockchain. Yeah, definitely it will work, but we have to update, and it is very customizable, and you can add so many parameters as much you want, and it is it's a very flexible, you can say, according to your blockchain system.
Thank you, I appreciate it. Any other questions from the speakers? Because we do have to move to our next presentation. If you do have additional questions, please kindly type it in the chat so the speaker can answer. Anisha, we could go to the next presenter. Thank you.
Okay, so thank you so much for the presentation. And now we are moving forward to our next presenter. And I would like to invite Sara Dursky to present her paper on the title, Digital Reading Fluency Training for Primary School Students, Concept and First Results. So dear presenter, you may please present your paper now.
Thank you. Hello everyone. I'm from University of Education Weingarten in Germany. First of all, I would like to show you my agenda. I start with the problem, then state of the art, objective, and I show you my research question. After that, I will talk short about the methodology, and then I present my concept and how I evaluated my concept, and at the end I will give a short outlook. The problem is that primary school students have significant deficits in school language reading competence, and also the heterogeneity is present in the area of reading competence. The basis of a good reading fluency is a higher reading competence. In Germany, 99% of households with children have a computer, a laptop, and internet access. Despite these new technologies, media-based learning and computer learning are only used in a limited extent in schools. But the use of new technologies in the school can have many benefits. For example, it is possible to learn at any time and anywhere. And the use of new technologies in the school context offers great potential for individualization and personalization. Reading fluency can be trained by reading out loud repeatedly. There are different read aloud methods like the real theater. In the real theater, students train cooperative dialogical text. This text are divided into speaker and narrator roles. And after the training, the students present the text. In addition to the training in the classroom, it is important that the students train in self-learned phases. And the problem is in the classical real theater, which is performed in the classroom, it is very time-consuming. And when students learn at home reading out loud, not every student had the opportunity to practice the dialogical text with a reading partner because the parents are at work or don't speak the language. So for these reasons, I want to develop a digital solution to improve the reading fluency for primary school students. It is a one-to-one training program and based on the real theater method, but don't only based on it, it is a future development of the method. And the digital solution includes innovation and personalization possibilities by using aspects of additive learning and interactive storytelling. In additive learning, the learning progress is monitored digitally. Dynamically and individually, the learning content is adapted to the students' performance. So students can work through already known topics more quickly and have so more time for learning content that is still unknown or problematic for the students. Interactive storytelling is an interactive process that creates a dynamic narrative. The user has the possibility to influence the later course of the story by making his own decisions, and interactive storytelling can inspire students and can promote language learning. So my research question is, how should a digital learning tool for personal and individualized reading fluency training be designed to be accepted by students? In my work, I use a design-based research approach, and to answer the research question, I would like to find out if the combination of additive learning and interactive storytelling is accepted by students, and how's the usability of the tool. For this, user tests and interviews were made, and the target group for the research are 3rd and 4th grade students with deficits in school language reading fluency. Now I'll present you my concept. The students can practice reading aloud on their own. For the reading fluency training, there are different reading fluency tasks. And a few minutes ago, I said that not every student has the opportunity to practice reading with a partner at home. With this concept, with this digital tool, the students have the possibility to practice reading with a reading partner at home. So the computer serves as a digital reading partner, and the system takes over the reading parts of the text, and the tool serves as a speech model. In addition to the reading fluency training task, there are also text comprehension tasks like a quiz. So that in the concept, two approaches are combined. So firstly, adaptive learning. Future learning content is dynamically adapted according to the learner's performance. Learners get direct feedback from the system. So, for example, a student who has finished a task well gets a different future task from the system than a student who has finished the task not so well. And secondly, interactive storytelling is part of the concept. In the learning tool are short videos. This videos guide the student through the learning tool and tell a narrative of a story. The students can make decisions, and depending on the decision, the plot of the story is influenced. In the tool, it is implemented in such a way that after a video, the student can choose between two different options, and depending on the decision, a new video is shown. So here's a screenshot of the tool. After watching the video, the student can press one of these two buttons, and depending on the decision, another video comes on. So the student has the possibility to choose one of these two story ways. And here is here you can see both approaches are used together in a branching path. Orange is adaptive learning and blue is interactive storytelling, and this is only a little part of the whole branching path. So now I talk about the evaluation. We implement the concept in a prototype and test it with usability tests and interviews with 15 primary school students, and each student needs 20 minutes for the whole test. During the test, the students first got an introduction to the content and the tool. The students was tried with the prototype on their own. The students were asked to share their thoughts aloud. And we did interviews with questions about acceptance and the future use. The results of the evaluation show that a combination of aspects of interactive storytelling and adaptive learning is possible and accepted by the students. The students rated the tool as very positive. They would use it in the future. They found the videos easy to understand, but longer speech pauses in the videos were requested. And in the videos, a computer voice would be used through the text-to-speech technology, and a human audio recording would be better. So at the end, a short outlook. In the future, the videos must be improved on the basis of the evaluation results. The prototype will be further technically implemented, and further evaluations should be made with a further developed prototype, also with a larger sample, not only with students, but also with teachers or experts. So thank you very much, and my references.
Thank you. Are there any questions for the speaker? If that's okay, I'll start. I have a question specifically related to your adaptive model. If I understood correctly what you said, currently the adaptability is based on the fact that you test how is the student performing reading, and the adaptability is on the fact that the tool now, if the student reads very well, moves to the next story. If the student doesn't read well, they get an additional actions. Do you foresee some other adaptive methodologies to be implemented in this tool?
Other implementation. So do you think in the part of additive learning, or?
Yeah, so I'm thinking right now, the edited learning is that the student, you track students' performance. You kind of look how fast or how fluent they are in reading, and then you move them through the story and you go back to the story. Are there any other methods you think of including? Any more options that the students will have? What do you think is the next generation of enhancements? Because you said you will have videos, but anything different videos, anything else?
Yes, I think that's what you say is the next generation, because now additive learning only works in our tool with, for example, the quiz as the text comprehension, and not with the reading performance, because because for digital feedback for the reading fluency, you need KI, and so yeah, I think that is the next generation.
Yes.
Thank you.
Yes, I have another question, Sarah. As you mentioned, from this video storytelling, it's very good for the third and fourth students. Disadvantage of this particular video-based storytelling format.
I think we had hard. Yeah, I
I
also had hard time hearing.
Yeah.
Okay. Maybe write it in the chat. I don't really understand it. In the videos for the interactive storytelling, so the students can choose in which way the narrative of the story go on. So, but I don't understand the question. Sorry, it's the connection, internet connection is maybe not so good.
Okay, no problem. Okay. Yeah. Is there any question for the participants? I think no. Anisha, please go ahead.
Yeah, okay. So thank you for the presentation. And we are moving forward in the session, and I would like to invite our next presenter, S.E. Ramirez Dominguez, to present her paper on the title High Sensitivity Transimpedance Amplifier for MEMS Micro Sensor Readout in Acetone Vapor Detection. So, dear presenter, you may please start your presentation.
Hi, sure. Let me share my screen. Can you see it?
Yes, we can see it.
Okay, so greetings everyone. I'm Sofia Ramirez, and today I will talk to you about a work I've been doing during my master's degrees, along with my IC and MEMS laboratory team at the Research Center of Micro and Nanotechnologies of the Universidad Veracruzana in Mexico. The content of this presentation may include a short introduction to the topic, research problem, related work, proposed system overview, circuit design, some results and conclusions, and if there's any questions at the end. Okay, let me start this presentation talking a little bit about MEMS technology. MEMS or microelectromechanical systems are a technology of integrated devices that combine electrical, mechanical, and circuitry, and all working together for a single functional requirements. These systems are capable to sense, control, and actuate on the micro scale and generate effects on the macro scale. MEMS sensors brings a bridge between the analog world to the digital world. In them, the electrical and mechanical elements are designed to sense the physical quantities like maybe pressure, gases, concentration, humidity, among others. And they convert this information to electrical signals like frequency, current, or voltage for further processing. This technology for MEMS sensors can be developed using CMOS integrated circuit compatible batch fabrication technique together with micro machine processes. The advantages of doing this or having this approach are many, like the cost of the fabrication is lower, the size and the interconnection along with some electrical issues are minimized, and its the reliability is improved. So we can find some sort of MEMS sensors in all kinds of industry, like automotive, telecommunication, environmental monitoring, and medicine fields. Is in this the latter that has highly benefit and in which I am focused is in medical industry. Due to the advantages for developing diagnostic instrumentations and for portable instruments, sorry. This makes possible to implement CMOS MEMS technology makes possible to obtain small devices with capability for reducing the time and cost of clinical analysis. In this sense, diabetes is a disease that seeks to benefit from this approach. The importance of screening systems for diseases like diabetes is the fact that although this illness is one of the oldest recorded, there is still no cure for it. And if it is not detected in time and it's not given adequate treatment, it generates various complications. Nowadays, the most common diagnostic methods currently are biochemical tests performed at laboratories, some glucometers, and also there are some people to prefer or maybe have to use implantable continuous monitoring sensors. All these methods are accurate, but implies an invasive need for skilled personnel, expensive, painful, and risk for infection process. This is why one non-invasive strategy for this is the analysis of volatile organic compounds, or VOC, emitted in the Excel breath with information relevant to the disease. This is the detection and analysis of biomarkers. In the case specifically for diabetes, acetone vapor present in the Excel breath of patient has proved to have a positive relationship between the concentration of acetone vapor in the breath and the concentration of glucose in the blood. So this VOC, of volatile organic compound, has been shown to be a reliable and non-invasive biomarker of the disease. The problem about this is the low concentration of vapor acetone in the Excel breath. In healthy individuals, it ranges from 0.3 to 0.8 parts per million, while in diabetics, it goes from 1.8 parts per million and above, which would be the limit of detection for the device. And let's also consider that human breath consists of a large mixture of inorganic compounds such as carbon dioxide, nitrogen, oxygen, and also inert gases and hundreds of VOCs. So we are talking that we need to develop and design or the ideal gas microsensor for this application would be a really highly sensitive microsensor capable of detecting sub-part per million level. Some related work in this sense is shown in the table on the slide. And then I would like to mention that the main parts of a CMOS MEMS microsensor are the sensing layer, the MEMS transducer, and circuitry for the readout and all the proper use of the signals. Although the development of gas microsensors is very broad, those under development and under CMOS MEMS integration perspective, specific to diabetes are limited. I won't take too long on this slide, but according to the principal parts of a microsensor, we can see on the table that the research that is in them presents sensing layers, limit of detection proper for the application, depending on the working principle, if they might need a heater or some other kind of part in the microsensor. And and for this work, we are concentrating a little bit more about the circuitry. If the related work is considering an on-chip approach, and if they are considering the design of a circuitry, a proper circuitry for the readout of the MEMS sensor. Having this previous research in mind, we started we proposed a MEMS sensing approach in order to focus on the design of a CMOS readout circuit that meets the specifications established for certain transducer. The proposed topology is shown in the figure. This type of MEMS is known as a chemical mechanical microsensor, or maybe we can also, it's also known as a microsensor sensitive to mass change. It's a parallel structure with electrostatic actuation and capacity detection. The lower plate or electrode is fixed and the upper plate is movable, and it's chemical functionalized by an acetone vapor highly selective material. This transducer responds to the mass of the analyte accumulated in the receptor material or the sensitive layer that is in top of the MEMS. And the mass changes can be monitored by detecting the displacement of the upper electrode. The mechanical movement is converted to an electrical signal. As I mentioned before, it can be depending on the actuation principle and the detection principle. It can be frequency, voltage, or current. So this signal can be later detected by the circuitry design and use. Well, for the circuit design, we implemented an equivalent electrical model for the MEMS structure that I previously showed you. For this, we took reference data as physical dimensions, actuation voltages, and frequencies from the state-of-the-art and previous work from our research team. Our goal was to obtain the electrical behavior of the prototype. And in this case, the variable of interest is the current signal. We were looking to know the current generated by the MEMS. We can see in the table that the amplitude of this current is in the nanoamperes range, and the voltage difference of the structure is of a few tens or tens of millivolts. This is due to the restriction generated by the bias voltage, the mechanical displacement, and also because our MEMS represents a high impedance node. So with this information, we know that we desire to design a high sensitivity or high gain circuit for the readout. And with this, we propose and we design the topology that is in the right side of the slide. And this is known as a current to voltage converter circuit, or also as a transimpedance circuit. It's based on it's based on the principle of reading the current produced by the MEMS, amplifying the signal and delivering as a voltage to the next stages. Also, this approach can be interpreted as the implementation of a current control voltage using a high gain op amp. And in addition to have this high sensitivity condition needed for the application, we implemented a T configuration network. And yeah, so with this design or with this approach, we start a test bench in SPICE tools to check the feasibility of the proposal and to obtain the desired specifications for the analog design of the operational amplifier in the circuit at the transistor level. That would be the next step in the design. The specifications obtained in the previous simulation or in the test bench are shown in the table on the left side of the slide. And we propose, or we decided to design a two-stage operational amplifier to meet the needs that the simulation show. The design was made with CMOS technology of 180 nanometer channel length, and with design rules of the TSMC company. We also have some values set by the technology, like the supply voltage, the technology and some others. And also, well, some of the specification given by the previously simulations are like the unity gain bandwidth, phase margin, power dissipation, and the gain. So the figure presents the frequency response. The figure in the low part of the slide show the frequency response of the operational amplifier, and we can observe the behavior and the results of the circuit. In this case, the circuit has a gain of 62 decibels for a phase margin of 62 and a gain bandwidth of 20 megahertz. Once we obtain the specification that we were looking for, that all these test bench and simulations have shown that were needed, we established the we implemented the schematic of the readout circuit that we presented earlier, with all the parts that form it, like the operational amplifier, the transducer electrical model, and also the T high sensitivity network. So we can do the transient analysis of the system. And well, it doesn't show in the graph, but we got a gain ratio of 280 from this design. Also, we made the layout design, the operational amplifier layout design, with a final area of 82.8 microns by 43.2 microns. So far in the investigation for a CMOS MEMS microsensor for non-invasive diabetes detection, we got the next conclusion. A CMOS readout circuit was proposed, designed and simulated for a MEMS transducer in VOC detection for diabetes treatment. Some of the characteristics we got are preliminary results confirm the feasibility of proposed system. A readout circuit with low power consumption. We got a high gain or the necessary for the application. And for future improvement or future work, we are considering just for the electronic part, some noise analysis and some to apply some offset cancellation technique. And lastly, I would like to show you some images from the research center we are, where topics like nanomaterials and microelectronic is studied, and the state is Veracruz in Mexico, next to the Gulf. And thanks for your attention.
Yes, a nice presentation, Sophia. So, but I have one question: is that what are the characteristics of CMOS technology?
Sorry, can you?
What are the characteristics of CMOS technology?
Yeah, sorry, I also have the.
Yeah, he was asking, what are the characteristics of CMOS technology? You had a slide with your 180 nanometers
Yes.
technology for CMOS. If you could just go back there. Thank you.
Yeah, we were considering the TSMC company design rules with 180 nanometers length channel. And also the supply voltage we implemented was 1.8 voltages. We used the GM-ID ratio methodology and what got 25 microampere current reference. Yeah.
Okay. Yes, ma'am. Over to you, ma'am. Over to Anna, ma'am.
Sorry, I don't have a good sound. I can hear well.
Now it is okay.
He's saying over to Anna, ma'am.
Okay. Yeah, I was going to say, because your voice is a little bit breaking. Again, I just want to thank you for your work. I think the one question I had for you here is clearly you're focusing this design to make sure that the CMOS and capabilities of the circuits are sensitive to the parts per million. So this is the semi-chemistry and physics combined, right, for your parts per million. But I have a different question. I wanted to go back to the CMOS design. How sensitive it is into the releasing I'm assuming it's a multi-breeder, so you can breed it one, then the system will relax, and then you will breed one more time, right? So how sensitive it is to the quick changes? Do you imagine it as a one-time use, and then you have to develop, or could you just comment on some usability for a variety of testings?
Yeah, some of those, or I don't know, most of those characteristics are appropriate or are intrinsic for the sensing layer or the sensing material. I mostly focus on the circuit design, like saying for a high gain or noise studies. We consider that it's, like you said, a multi-breed technique, and some of the materials that are ideal or used for this application are some polymers that have shown to have this characteristic with wood response for releasing the molecules, but that would be like the sensing layer part. Or
yeah, I understand. You're working on design and the release, and then re-establishing the baseline will have to be a future work. Understood.
Yeah.
Thank you. Really, really interesting. Really
Thank you very much.
Thanks.
So thank you so much for the presentation. And moving forward, I would like to invite our next presenter, Joseline Zapata Polini, to present her paper on the title Implementation of an ERP system for the improvement of the logistics process in an SME. So dear presenter, you can please present your paper now.
Yes, I can see my screen.
Yes, we can see it. But if you can try to make it full screen in a slide mode. Yeah, now that's fine.
Okay. Good afternoon, those presents. I'm going to present the research paper implementation of ERP system for the implement the logistics process in SME. The content, introduction, methodology, results, and conclusion. Introductions. And companies' environment is characterized by globalization and highly competitive environment for companies, which are increasing interest and achievement and demonstrating solid operation performance through the technological tools and their disposal. And likewise, to make profits and achieve the highest possible productive and profitability, and this most clearly understand how satisfaction in internal and external customers. The implementations of process manager has proven to the perhaps the most effective business management tools for any type of organizations. A small and medium-sized enterprise play fundamental roles in the national economic by contributing the jobs creations, in decreasing poverty and in increasing GDP. However, in Peru, there is no standardization of activity in business automation process, which is useful to improve the orientation of effort and developer of business process resources. What's ERP systems? The enterprise resource planning, ERP, is a set of management information system that allows the integration of the company operates special in the production, logic, inventory, and costs. It makes it easier the optimize process and obtain information faster and more accurate. And the reports proven by the system are 100% accurate and obtain the rich information and the rich time and mapping the process for any point. ERP system for S and is ERP allows owners and managers of large or small companies the evaluate implement their internal process and other advantages. Increase the percentage in technologies adapters of the SME allows for better planning and control of business resource, grace management capability in small business, contributing to the flexibility and agility. ERP failure factors. And no integration in insufficient integration leads to loss of competitiveness. And the times for some business process cannot be reduced in manual interpretation, any results in redundant and inconsistent data. In other hand, it is important to select a type ERP to the use above all to be clear about the objectives and process of the business, since the ERP system will be adapted according to this in the line of the business. Methodology. Scrum methodology is simpler and more flexible, and in the under project is defined and main events of the sprint that correspond to time windows and when usual versions of the product increments is created. Each sprint is an independence project. The objects to determine the influence of the implementation of the ERP system and the improvement of the logistics process, and SME taken a boutique of the object of the study. Research design type. The research is considering quantitative, focusing on the study and analysis of the problematic reality. Likewise, the type of the research was applied. Population and sample. Population purchases made between the month of November 2021 and May 2022 in the boutique company Única, located in Trujillo, Department of the Libertad, Peru. Sample 20 purchases operation identified in the population. Spring 1. The interface to access the system logic was developed, and the user administration interface was developed has functions in the maintenance of users. Among its action is to add, edit, disable, enable, and view data. Sprint 2, the action disable and enable users located in intro were developed, where the clicking on the button, the color change according to the options, the interface approving meaning of the product category was developed with the action and edit. Sprint 3 action we developed for the garment administration interface to main categories with the functions and edit and research sites, and the shades, the add, garment, edit, and register size module located in the garment tray and the top were developed. Sprint 4 actions were developed for the supply administrator interface to mine superly with functions add, edit, enable, and disable. The Sprint 4 actions for the sales administration interface were developed in the section sales are maintained. And the strength add information model was developed, located at the top, the try of entering the vouchers, the customer, and the payment methods. The add detail button is enabled. The Sprint 6 actions were developed for the purchases administration interface in order to make purchases in the functions and export Excel, contemplate the data requests by the systems. Is the strength, the add information model was developed, located in the top right. After entering the vouchers, the voucher number is displayed and the add detail button is enabled. Sprint 7 action we develop for the customer administration interface in the order improving customers maintain results. In the resource direct observation was used the examined the process environment in the purchasing process and the measure and the time it take to perform each operation. An interview was also elaboration considered 4 questions referring to the satisfaction after each purchase operations. After applying the instruments, we process and organization the information in respective analysis. With respect the dimension in indicator 1, purchasing time, provisioning by purchase time can be observed that in the pretext and valued 163.4 was obtained on the average and the post-test of the 90.5 with the results reductions of the 45.6% in purchases time can be seen. Indicator 2, satisfaction of supply managers according to the results obtained with the respect to the dimension of provisions by the satisfaction of the tools in shares of provisionings. It was obtained that the pretext in the May was 1.8 and the post-test it was 4.5, with the results increase of 150% can be seen. It can be seen in the pretext 25% of the corresponding rate very dissatisfied and 20% undissatisfied and 5% rate and average and of the post test 55% corresponding and rated as satisfied and 45% is very satisfied. Conclusions. SMEs today have been forced to develop new strategies that allow the growth and the research more users. After analyzing results, is included the ERP system have positive influence in the purchasing time or the unique stores, allowing and time reductions. And likewise, ERP system has a positive influence on the certificates of stores in shares of supplying the unique stores, allow an increase in the degree of satisfactions. And finally, is experience to be great help for small and medium-sized companies in the clothing sales area to obtain and know and they have a guide of the implementation and startup of an ERP systems, free software, and obtain benefits with making a costly investments. Thank you.
Yes, very good question and very good topic. I hope I'm audible to you. Yes, I'm audible.
Sorry, I don't understand.
My question is that how you calculate pre and post time, and what will be the formula for the pre and post time calculation?
Oh my, I don't understand. Sorry. Yeah, the microphone.
So Professor Akashi, it's really hard to hear you. I did wanted to comment for the presenter. It just happened that yesterday I gave a presentation of future of procurement. So this topic is clearly important to me. And I think what we all see is that in the future of procurement, you really want to have this interconnected ecosystems of big corporations with small and medium businesses. So the first step is to, of course, digitize the small and medium businesses and have the data flow. I wanted to ask you just one question. You said that you used 20 procurement operations to test your ERP system. Can you just comment those 20 operations? Were they a typical processes in the ERP system that you would expect, or were they very specific to this one garment store? I just wanted to learn more. What were the 20 operations, 20 parameters, 20 procurement operations that you chose?
Okay, the ERPs can be adapted in any company, especially to reality production, logic, inventory, and costs. In addition, is possibility the optimization of process and obtaining information more quickly and accordingly, will allowing all users to share information and access in constantability.
I mentioned my question in the chat box.
I understand. You're commenting on the fact that it's ERP systems are developed for multi users in various industries. So the basic operations you chose should be common for others. Understood. Thank you. All right, Anisha, I think unless there are any other questions, please go ahead. And then Professor Akashi, thank you for typing your question. Really appreciate it. So if the speaker could kindly answer the question in the chat, really appreciate it.
Yeah, no problem, no problem. Please go ahead.
Thank you.
Yes, ma'am, please go ahead.
Okay. Yeah, so we are moving forward to our last presentation for the session. And I would like to invite Purab Nandi to present his paper on the title, Machine Learning Algorithms for Geriatric Fall Detection with Multiple Data Sets. So dear presenter, you may please present your paper now.
Am I audible? Hello.
Yes, we can hear you. Thank you.
Okay. Thank you so much. Good afternoon, organizers and the fellow presenters. I am Purab, and my topic of today's presentation is machine learning algorithms for geriatric fall detection with multiple datasets. I'm currently pursuing my work at BITS Pilani Goa campus under the guidance of Professor K.R. Anupama. So coming to today's agenda, this is the agenda for today's presentation. Now, starting with the introduction, based on the current WHO statistics, the speed of aging is increasing rapidly. The percentage of population residing above the age of 60 is more when compared to percentage of population residing below the age of 5. It's predicted that by 2050, the geriatric population will increase from 12% to 22% of the entire world population. And around 80% of the elderlies will live in low and middle income countries. Now, due to multiple health-related issues which comes due to aging, like aging organs, weak exoskeletons, etc., they are more prone to falls. And the fall statistics that has been gathered says that more than 40% of people who fall cannot get up on their own, and they need some sort of assistance to get up. And around 50% of population who experience a long fall eventually die within a few years. Now, the previous work that has been performed is on this fall detection mechanism are mainly classified into image sensing based and IMU sensor based. When we talk about image sensing based, it's primarily the use of multiple cameras placed at different corners or points in the room. And it, based on the images that it collects, it can predict if a fall has occurred or not. The next one is IMU sensor based. IMU is essentially inertial measurement unit sensors. So they comprise of 3-axis accelerometer, 3-axis magnetometer, and 5-axis gyroscope, among other sensors also. Now, these sensors can be placed at the torso, wrist, ankle, and thigh for accurate detection of the sensor values. Now, wearable-based systems these days are primarily using only IMU-based sensors for the detection mechanism. Now, coming to the smartwatch-based system, the algorithm used to predict falls are mainly classified into threshold-based algorithms and ML and DL-based algorithms. Now, coming to a case study of the threshold-based system, there was 10 males with no existing health issues who participated in the study. 8 fall activities and 12 ADL activities were performed. ADL means activities of daily living. And each of these activities were repeated 3 times. However, it is important to mention that the ADL activities were performed by elderly people. The elderly people did not perform the fall activities. The fall activities were performed by normal people or young people. Then a threshold-based algorithm was implemented on the data collected, which was angular velocity and position-based acceleration. And the results were that the hard falls, the values where the acceleration value was more than 6g was detected fine, but soft falls where the acceleration value was ranging from 3 to 3.5g were ignored. The next one is ML-based mechanism. So coming to the case study, it used an RNN-based architecture, which also used a 3-axis accelerometer, and it was placed in the pelvis region. The output of the RNN model is fed into 2 LSTM models and further into 2 feed-forward neural networks. And finally, we collected the UR fall dataset. The UR fall dataset is an online-based dataset which is used for fall detection, and it is available for free. Now, the use of multiple data sets and their performance on a single ML algorithm has not yet been considered in fall detection mechanisms. Some current work focuses on the use of feature extraction from data sets, but not much work has been done in that. However, when it comes to fall detection, same data set is primarily used for training and testing. That is the random split of 70-30. That is the standard way how it is done. But when we consider parameters like age, gender, weight, health conditions, and other parameters and split them in testing and training, the performance may vary. Now coming to the IoT architectural models for wearables which are available in the market right now, as you can see, model A and model B are essentially the ones that are, for example, if you can say the ones like health bands, MI health bands, OnePlus health bands, example. So in this, the bands are just collecting data and transmitting it to the coordinator. Coordinator is essentially your phones. So you know how the data health band collects the data, sends it to the phone, and the phone is in turn connected to the internet and the cloud will be running the long-term and short-term ML algorithms. Model C will have a more complex wearable device, essentially Samsung Watch or Apple Watch. They will be collecting the data, cleaning the data, and also perform the sensor fusion on it. Again, it will transmit it to the coordinator, and finally the coordinator will send it for the long-term monitoring. We are currently working on developing a model D, where the wearable device will be able to collect data, clean the data, perform sensor fusion, and also run ML and DL algorithm on it for short-term health monitoring. And then it will transmit the results to the coordinator, and again, it will be fed to the cloud for long-term monitoring. Now, the use of multiple data sets. As you can see, we have multiple data sets all available online, like MobiFall dataset, SmartFall, SmartWatch, Notch, etc. These data sets are available online and they are primarily used in fall detection mechanism. Our paper primarily focuses on the study of the impact of certain classical ML algorithms like random forest, LR, KNN, and naive Bayes on the impact of accuracy on using entirely separate data sets for training and separate data sets for testing, instead of the traditional test train split. In our paper, we used 3 public datasets, and we also collected our own in-house dataset from scratch, and we performed the analysis on them. Now, there are certain issues while using the public datasets. Now, datasets which are available in public are massively distributed, private, and unbalanced. So there are certain challenges available with it. So while using a public dataset for healthcare industry, we must perform these certain checks. The first is sanity check. So in this, the researcher will inspect a random example of data to check the size, the type and range, and identify the outliers. The second is model debugging. The modeler will check for the misclassified examples and look for issue in features or labels. The third is data labeling. So when we deal with large amount of data, the low accuracy observed when the data may be incorrectly labeled. So it needs to be checked and labeled correctly. And the final is detecting bias in trained data. So each data set has a bias when multiple data sets are used to compile them. So in case public data sets, they must be checked and corrected. So in this paper, basically, we will try to do a comparison of the effect of single data set versus multiple source for testing and training and see what's the effect of it. So for our in-house data preparation, we had current sensors which are used are mainly IME and biological sensors. So biological sensors are heart rate sensors and pulse oximeters, and wearables are preferred because elderly can carry with them. They can be placed at torso, thigh, on wristband. Wristband systems are more preferred because they can monitor the external parameters related to short-term emergencies. And existing fitness bands have been built around SOCs and they can be used. These fitness band, all of them have one sensor is common, that is IMU sensor. So when we consider the data collection methodology, so when we collected the BITS data set, we made the volunteer perform certain ADL activities. ADL are basically activity of daily livings. As you can read, these are the various activities our volunteer perform. So it was mainly walking slowly, walking quickly, jogging, climbing up and down, and you can read the rest. The volunteer then also performed certain fall activities. It was done in completely padded chamber. So the fall activities that were performed was forward fall, backward fall, lateral falls, and grabbing while falling. So we tried to emulate certain falls in completely experimental based chambers. Now, when we collected the BITS data set, as you can see, the data points that was gathered was around 48,000. The notch had around 11,000. The smartwatch had around 35,000, and the smartphone had around 93,000. When we come to the, since we collected the BITS data set, we had more details available to us regarding that. So the age was varying from 20 to 22 years. The height was 5'1" to 5'8". The weight was from 40 to 75 kgs. And they did have certain pre-existing conditions like malnutrition, vertigo, claustrophobia, and diabetes. And we used TicWatch to collect the data. Now, Notch, smartphone, and smartwatch data sets are publicly available data sets. We did not collect them. And you can see their age, the number of subjects is given in the table. So when we ran the 4 algorithms, you can see KNN, LR, NB, and RF. We can say that in the first graph, we used BITS data set. Now the orange one, it shows that we used the single data set randomly split. And the black one shows we separated certain data sets, data points for training and certain data points for testing. So you can see that there is a considerable drop in the accuracy. But however, in case of random forest, we see the change is negligible because in case of random forest, it employs multiple decision trees that progressively learn from each other. So the change is minimal. Now the next results, we can see Notch dataset, which is 70-30 split, the traditional split versus smartphone dataset for training and Notch for testing. Now, please note that Notch had the lowest number of data points. That was 10,500. And smartwatch was having a data point of 35,000. So you can see a big difference in accuracy when we use Notch for testing, because it doesn't follow the cardinal rule that we must have a large data set for training and a small data set for testing to get accurate results. The next one you can see is, again, we use the Notch data set. It has less number of data points. And you can see that logistic regression gave a better result. It mainly gave better result because least amount of drop in accuracy. It works best because it can be easily updated to reflect the changes in new data and also due to linearly separable data. It performs better even when random forests saw with a dip in progressive learning. The next one is for smartwatch dataset. So the first graph you can see, the black one is essentially smartwatch dataset itself in a 70-30 split. And the orange one is Notch was used for training and smartwatch was used for testing. Again, Notch having less number of data points than smartwatch, it gives a bad result. When we come to the next graph, we see smartwatch dataset having a 70-30 split and smartphone and smartwatch dataset for testing. So it gives nearly same results because the data size was comparable. So in all these results, we can come to a conclusion that if you have good amount of data points for testing, but you have to have, even if you have a good amount of data set for testing, you must have a very large data set for training to get very good results. So coming to the conclusion, we would like to say, why do we want to incorporate federated learning? So essentially, federated learning is used to train decentralized ML models across multiple edge devices. Compared to the classical ML technique where we have data collected from multiple sources, they are centrally stored and then a model is trained on it. But in federated learning, the trained model is brought on the edge device, and based on the data collected on the edge device, it is iteratively retrained and the model gives a better prediction result. So federated learning is still relatively new and is yet to be implemented on fault detection based mechanism. So when the test trained demographics are completely different, if an insufficient number of activities were performed, then there is a big drop in the accuracy. So we propose the use of federated learning across a distributed dataset source collection from multiple similar public datasets. So our future work will primarily focus on fusing federated learning with incremental learning in decision trees to develop an optimal ML or DL based model that can be used for medical grade applications. Thank you.
Now I have to in the chat box. Please.
Yeah, I was going to say thank you again, especially since this is our last speaker and we are run out of time. So I just really want to thank everybody for staying longer with us. Really, really appreciate it.
What is the difference between the federated learning and distributed learning?
Sorry, sir, could you repeat the question once more? It's a bit difficult.
I have mentioned chat box.
Oh, sorry. Just a second. So essentially, federated learning is, let me tell you an example. Like, for example, if you consider the wristband-based health bands, okay. So when you consider that device, if you train an ML model, you will be having a completely different data set, right? The first time you deploy your model, the data set will be collected from multiple people who will be in, let's say, an age range of 20 to 35. Because you can't ask the elderly to fall, right? So when you have that age range training a model, and if we deploy that model in a wrist device for geriatric people who are aged people in the range of 60, so there will be a large disparity in the readings, right? So in case the young people get a fall at around, let's say, X value, the X value may not be the case, or it may not have the same value when it comes to the elderly people.
Okay.
So federated learning, essentially what it says is, I will only deploy the model on the device itself. Okay. And on the device, the data will be collected and it will be training it and it will be sending back to the cloud again. And this will be happening iteratively so that the model can predict better.
Okay. Okay. Thank you very much.
Thank you again, the speaker. Anisha, I think we're ready to close. Really appreciate it.
Yes, so with that, we have completed all our presentations for the session. And I thank our last speaker for the presentation. Yeah, so for now, I sincerely thank our authors for their excellent presentation and contribution in the session, and all our participants for being a part of this international conference. I hope the session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this 8th version and the previous 7 versions of the conference. And we will be happy to have you in the 9th version in 2024. And now that all the presenters would be getting their digital certificates through email within 2 working days, and further all the papers have already forwarded to Springer. The publication will be live within 6 months. So kindly cooperate with the team of ICICT 2023. I would also like to thank our session chair for chairing the session. And here is a small token of appreciation on behalf of the team of ICICT and Global Knowledge Research Foundation. and partners. So thank you so much for your valuable presence, session chairs.
And
Thank you.
Manisha, thank you so much for hosting this today and moderating.
Many thanks to everyone present in the session. Thank you one and all.
Okay, thank you. And as we have come to an end of the session, I request you all to please switch on cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.
Thank you. Bye-bye.
Bye.
Bye.